Hello crew, this is lesson 6 of our Scratch class. This time we are going to learn about 2.5D, and we're also going to make a forever scrolling background. And to that you say, what is a 2.5D? And 2.5D, or 2.5 dimensions, it's all about faking a 3D look. You just use some sleight of hand to pretend things are three-dimensional. And you trick the eye. Let's go over 1, 2, and 3 dimensions real quick. 1 dimension, it's a point. I don't know how to draw that. It's like you can't even see it. So I can draw a 1-dimensional person, and that's what he looks like. A 2-dimensional thing, it's something you can look at like a picture, but it has no depth. If you looked at a 2D thing from the side, it would disappear completely. Do 2D things even exist? I don't even know. It hurts my brain. But I know that 3-dimensional things have volume, and you can eat them like a rock. A lot of fancy schmancy computer games, they use 3 dimensions. They model objects with X, Y, and Z coordinates, 3 coordinates. In Scratch, we've only used 2 dimensions. Remember, we place things on our 2-dimensional stage with X, Y coordinates. Well, a real 3D model in a computer has 3-dimensional points with X, Y, and Z, where X is the acrossness, and Y is the up-downness, and Z is the how far away from me-ness. But 3D math is trickier than I want to get involved in, so let's just mimic a bit about how things look when they move far away from us versus when they are close to us. Did you ever notice that when a kid runs across a field and is close to you, it hardly takes him any time to get from one end of your field of view to the other? It's like you can see that this kid just runs across the screen in just a couple steps. But when his clone is far away at the other end of the field and he runs across, he's tiny, and it takes his little legs forever to get across. So let's look at that one more time. When he's close, he's big and he goes really fast. Boom, he's across the screen. But he's really running as fast when he's in the distance. But it takes him forever. So we can do that in Scratch. We can control the speed and the size of sprites. So we'll make things that are far away move slower, and we'll make them smaller. And things that are close, we'll make them bigger, and they'll go fast. And people will be like, hey, look at that. There's 3 dimensions-ish. Do you guys want to see a preview of the project that we're going to do today? It's called Train Frog, so let's take a look. Just sit back and watch. The clouds, they're far in the distance. Take a note of that. They're moving slower because we just did that whole farther away seems to move slower. The mountains are a little bit closer. They scroll by a little bit faster. And the fly, I got it casting a shadow because, shadow. Are you guys ready for the drill? Let's just grab the starter project from T-Skolnick so that you have the sprites and the costumes that we need. And this time, we're going to use the Train Frog Costumes project. And once in there, we will hit Remix so that it becomes our project. And then let's rename the project just to Train Frog. Let's start by working on the forever scrolling mountain background. If you look around, you're going to find that there's lots of ways to do scrolling backgrounds. The one that I'm going to show you here is it's the one that's easy for me to understand. There's some more mathy ways, but I'm going to show you it requires 2 copies of the sprite that you want to have scrolling. You'll see that I have mountain 1, well actually just mountains and mountains 2, as well as clouds and clouds 2. And here's the gist of how we're going to do this. First, let's just have the mountains start all the way over to the right and then slide to the left, moving 5 steps at a time. My mountains are 480 points wide, which is the same as the stage, no coincidence. So if I set the mountain X position to be 480, then I know it will be just off the right-hand side of the screen. And are you ready for some hard math? I want the mountains to walk across the screen and stop when they fill the screen. So I know the mountain has to walk 480 points. If I'm going to walk 5 points at a time, that means that I need to figure out how many 5-step moves will it take to get to 480. I asked my wife, and she says 480 divided by 5 is 96. Let's make a repeat loop that goes around 96 times and then change our X position by -5 so we move to the left. And of course, we got to put our little weight in that we always put in there. 0.01 should do the trick. I should have done this before, but let's hide all the other sprites so that we just see the mountains and can tell if our code is correct. Just keep it simple. And it looks pretty good. I say it's good enough, and we can move on. Now, let's put in the forever loop so it keeps doing the same thing forever. Are you ready for this trick? What if I had an identical mountain sprite that moved just like this one, but was shifted 480 points to the left so that they butted up against each other? Butted. Okay, well, then the stage would be filled with mountains, and you wouldn't even see the seam between the two sprites. It will look like a forever scrolling thing, because the left side of the picture lines up perfectly with the right side of the picture because I did that. Here we're going to broadcast an event to the second mountain sprite so that every time we move the first mountain, the second mountain changes its position to be just to the left of this one. It's kind of like they're taped together, like one big wide thing. That's twice the width of the stage. We broadcast the event, move mountain. Yeah, you can't move a mountain. When in the other mountain sprite, we receive the event, move mountain, then you jump to the same position of the mountain, but shifted 480 points to the left. Okay, so we are in the mountains 2 sprite, and we're receiving the move mountain message. We know that when we receive this message, it's because the mountain sprite just moved, because it sends the message every time it moves. So we have to move the mountains 2 sprite so it's always just to the left of the mountain sprite. We can use the sensing block to ask where the mountain sprite is and make our y match its y, and then we stay to the left of the mountain. And to do that, what we do is we take our x position. Well, actually, we take the x position of the mountain sprite and subtract 480 from it. That's the width of the mountain sprite. Now, mountains 2 will forever stay to the left of the mountain sprite. And then we run it, and it doesn't work, and we start to question our life choices, and then we realize we forgot to unhide mountains 2, and then we see that it works great, and then we are reassured of our genius in spite of what our IQ score suggests. And that's it. You know what time it is. It's time for Geek of the Week. So this week's Geek of the Week is Margaret Hamilton. She headed the development of the onboard flight software for the Apollo space mission back when programming was done on punch cards and hippies wore bell-bottoms and fish could swim. Since she contributed so much to software, Margaret Hamilton was eventually awarded the Presidential Medal of Freedom and a whole pile of other awards, and I once won a cake in a raffle at Winmore Elementary School. When you next see Margaret Hamilton, please thank her for writing the software that keeps our astronauts alive. I think it's time to give the forever scrolling treatment to the clouds. And as you might have guessed, the code for the clouds is going to be oh so much like the code for the mountains. So let's start by grabbing the code from the mountain sprite and dropping it onto the cloud sprite just by dragging it. That's how you copy it in there. And you can see the cloud sprite wiggles just a little bit when you are in the right place to drop the code. And the word wiggle, it comes from the Middle Dutch where Frodo Baggins lived. Now, let's make the cloud go slower than the mountains by going one step at a time. It'll actually be -1 step because it's going to go to the left. In order to traverse the 480 points needed to scroll across the screen the whole way, I consulted the missus, and she said that 480 divided by 1 is 480. And since she's the brains of the operation, I say we give it a try. Every time the cloud moves, it needs to send a message to clouds 2 so that it can place itself just to the left of clouds, thereby covering the full stage, just like we did with the mountain. We're going to broadcast a new message, and this message is going to be move cloud. Oh, let's adjust one more thing. Let's adjust the Y position of the cloud to 10. Really, you can experiment and pick anything you like, but I think 10 is looking good. Now, let's perform the same operation on cloud 2 that we did on mountain 2. So we go to mountain 2 and just copy that code over. Once we're in there, inside cloud 2, we change it to listen for the move cloud message. Then we just change the sensing block we used to inquire about the position of the mountain sprite, and instead we make it inquire about the position of the cloud sprite so that cloud 2 can position itself next to cloud. Remember to make the cloud visible, and at first we see that it does not work at all. And so I take a moment to look at the cloud 2 sprite, and I notice that it says the Y should equal the X position of the clouds. And that is wrong. Somebody set me up because I didn't write that. Y is supposed to be the Y position of the clouds. Let's step back and see how this happened. When I changed the sensing block to go from the Y position of mountains to the Y position of clouds, it reset to be the X position of clouds, and I didn't notice. Does that make me a bad person? No, that particular thing does not. Let's run this sucker and then turn on the mountains also so we see both and yippee-ki-yay. So anyway, so take that, you Luddites out there. This is 2.5 mother loving D, baby. And it's true because my mother really is fond of 2.5 D. All right, guys, let's make the train car visible and then we'll step through the costumes. So you're going to see that the frog's head is not there in these costumes since I made that a separate sprite. Looking back, I should have put the frog's head right in this image. Regrets? I've had a few, but after all, I forget how the song goes. So you see we have a costume for each step of the tongue shooting out, and then we have 2 images of the blood spurting. When the program starts, let's make sure that the train car has the first costume, window no head, and then make sure that the train, this whole sprite, is in location 0, 0, so it frames the mountains and the clouds very nicely. I want the train car to bounce just a little bit so it looks like it's moving. And a forever loop's going to do the trick, where we're going to go 2 points up, then wait a random amount of time. We're going to go maybe 0.01 to 1 second, and then we move the Y position down by 2 points, and it'll look like it's, randomly bouncing like a train would. Then let's also play the train sound when the program starts. So the train's going the. I'm going to do the sound in another event block so that these bits of behavior, the moving up and down and the train sound, they just are going constantly and they're running in parallel. For the sound, I will take a forever loop and then I just play the train sound until done. Inside that loop, when the sound ends, it'll start up again. I want to have control over the timing of this farce. I will put the code that controls the timing in the background layer, just because I like to do that. When the program starts, I want to wait just a little bit before that refined woman on the left-hand side, before her savage tongue comes out and decapitates her cabin mate. 11 seconds, I think, will do the trick. And then I will broadcast the message strike, and we'll go back to the other sprite and respond to that event. Now we are back in the train sprite. When we receive the message strike, let's play out the whole animation of the tongue coming out and then the blood spurting bit that you kids seem to crave so much. I will start with the event block, receive strike, and this next bit is just a series of costumes that we step through. And after each costume, we do the usual wait. And we're going to play the costume out until the tongue is all the way out. We reverse the costumes until the tongue is back in. And then finally, we show the 2 blood spurting frames, and those blood spurting frames, we're going to put that in a forever loop, so that just keeps blood spurting forever when we step through the initial tongue sequence. What you'll see that I do here is, because the code is repetitive, it's like change costume, wait, I just duplicate the code block, stuff it, put them together, and duplicate that, and then suddenly in just a few moves I've got a whole stack of these things that I can then just edit. Let's step through the blocks to switch the costumes from tongue 1 in sequence all the way up to tongue 4 and then all the way back to tongue 1. And actually, we have to go to the starting costume that has no tongue at all, and that one is called Window No Head. It looks like, for some reason, I repeated the tongue 1 costume, but we will not speak of that. More interesting, I think, to speak of is the forever loop that we need to do for the blood spurting. Let's duplicate a couple of code blocks again here, so we have the change costume and wait blocks 2 times. We will change between costumes spurt 1 and spurt 2, and that's it. And then we play this out. We'll wait 11 seconds to see the animation. And that is downright poetic. But we need royalty-free sound effects produced with mouth sounds. Let's put the tongue sound in right after the first costume change, i.e. when the tongue first emerges. We want to use the start sound block, not the play until done business, because we want the animation to progress while the sound is playing. Life is short, and I can't wait a full 11 seconds for the tongue to come out every time we test this out. I want to go into the code that's in the stage that controls the timing, and let's just make it 3 seconds before broadcasting the strike message. Oh my God, this brings a tear to my eye. I can't resist one bit of tuning. I want to slow down the blood spurt, so we'll make it wait a tenth of a second between costumes. Let's get the frog head out there. On start, we'll set the XY position. I happen to know that -3, 0 is a good location. 0, 0 would have been fine too. I don't know why I did -3, 0, but so be it. You might think that the frog head would be in the center of the screen if it's set to 0, 0. But if you look closely at the frog head costume, you will see that they have a little marker that shows the center of the costume, and the head is like way off to the upper right. It is actually offset in the costume itself to the location that puts it properly right on top of the dapper gentleman's neck. Of course, we have to remember to show the head. So let's drop that in there. Now, when the tongue reaches the head and is covering it, I want the head to disappear. So I will broadcast a tongue out message to tell the head to disappear. Then, if we go back into the head sprite, I can receive that message and then I can hide. Yep, that works nicely. I really need the head to move up and down with the train car. So when the car bounces up, I send a bounce up message. And when the car bounces down, I send the bounce down message. Let's jump to the head and react to the bounce down and the bounce up events. We will just change the Y by -2 and 2. It's really a subtle difference, but it's nicer when the head moves with the rest of the body. This time I'm going to deviate just a little from the full sample program that we had in the beginning, where the fly was flying around, Frog's eye was following it, and then the fly settled on the newspaper. But since this video is kind of long already, we're just going to simplify it, and we're just going to have the fly sit on the newspaper, and it's just going to flap just a little bit. So for the fly, the first step is on the start to make it visible. Then we just add a forever loop that's going to switch between the two costumes that make up the flapping. And inside the forever loop, we just place a next costume block. Then we're going to pick a random number between like 0.5 and 1, and that's going to be our weight between costumes, just to make it look like real flapping so that we don't hear it from some irate entomologist. Now let's zoom into the code just a bit so we get a better look. Then you notice the newspaper is bouncing up and down when the train is bouncing up and down because it's part of the same image, and the fly is sitting on the newspaper, so the fly needs to bounce up and down. What we can do is just steal that bounce up and down code from the head sprite. And so we can go into the head, grab those blocks of code that react to the bounce up and bounce down and drop them right on top of the fly. Then we go into the fly sprite and we just tidy up a bit. And since we're simplifying the code here, we're not going to use that moving pupil sprite. And we're just going to draw the pupil of the frog right on his eye. I'm going to use the eyedropper just to grab the black color here, draw a small circle, and that's it. The last thing that I want to do is to change the timing back to 11 seconds before the tongue shoots out, because 3 seconds doesn't really allow the tension to build properly. Let's go back to the stage where that bit of code was, and that is it. We did it. Oh, if you want to go to the full program, you can see the full program under the name Train Frog in my account, in the T. Skolnick account. All right, guys, that is it for this week. And as always, thanks for coming and stay well.